Good day and welcome to this PowerPoint presentation. My whole aim is to help you and prepare for the examination. The instructions are very clear. I just want to make sure that you all know there's no rough work in mathematics. All the work that you do, all the working out, everything is part of your answer. It's part of your work. So never ever ask for extra paper or for rough work. Whatever you do on the exam answer script. There's 8 modules or 8 units in your guide. This is your guide, as it is called. And we are going to work through 8 modules, 8 units, and every single unit will be covered in the examination. You will get questions on every single unit. So don't skip anything. Don't think that this is not important or that is not asked. Everything is asked, and prepare well. Now, mathematics is not only the work that is in the syllabus. Remember, if you do history, you have certain aspects, you have certain topics, and that is what you write the examination on. But in mathematics, it builds on. So all the work that you've done in the first and second year, that is your basic, and that is your that is the pre-knowledge that you need to have, first of all, to go on studying this unit and this module, this guide. It's not that it's only this. To be able to do some things, you need the pre-knowledge. So I started with some basic knowledge, important for numeracy and mathematics. This is not in your guide, but this is the basic knowledge that you all really need to know. The number system. You've been learning the number system since grade 1, starting with the natural numbers when you started counting. And then we built on the counting numbers with the 0, the whole numbers, or integers, the other name for it, even numbers, odd numbers, square numbers. All these number systems you need to know. And you need to have a basic knowledge of them. Then when we get to word problems, there's certain words that you need to know the meaning of. Sum, difference, product, quotient, the signs, smaller, greater, etc. That it's important. This is just basic knowledge that you need to know to be able to do some maths. Rounding off. This is also not in your guide, but this is also some of the basic knowledge. Round off to the nearest 10 means you make full tens. Rounding off to the nearest 100, you make full hundreds. And remember, if you pass the halfway mark, you go to the next 100. If you didn't reach the halfway mark, you just fall back on the previous 100. Like rounding off the following numbers to the nearest 1,000, so we make full thousands. 4,245. Now, where's the halfway mark? 4,000, halfway to 5,000 will be 500. So the 245 did not reach the halfway mark. Therefore, we go back to the previous 1,000. So 4,000 is rounded off to the nearest 1,000. However, 6,878 will become 7,000. Because 878 is more than the halfway mark. So we reach study unit 1, which is standard notation, ratio and proportion. Standard notation. The basic rule, 1 non-zero digit before the decimal comma. So if you've got 837,800, now we look. 8 is my first digit, which is not a 0. So I count from the 8. The 8, after the 8 the comma must be. But now the comma is at the back of the 837,800. So I count backwards. 1, 2, 3, 4, 5. So I counted 5 digits back. Let me write it down for you. We've got 837,800. The comma is now at the back. There's no comma, but you know any full number, the comma is at the back. I want it to be after the first digit. So where does it go? I just write the digits there. I don't have to write those 2 zeros. So I count 1, 2, 3, 4. I went 5 places back, so that's why it must be 10 to the power of 5. If I say this, 8.378 times 10 to the 5 means I multiply with 5 zeros, which will get me that, because that number and this number must be equal. And if I work backwards, like 9.85 times 10 to the negative 5, remember, I want to make this now, like write it in as an ordinary number, number 2 there. So I have to count now, not on, but backwards. This is now, I start here, and I have to count 5 places back. 1, 2, 3, 4, 5. So my comma must be there. So here I have to put in zeros. So what do I have? 0, comma, and 1, 2, 3, 4. And then the 985. So I hope you can use these exercises, these few problems that I gave you, to practice going forth and back. Writing a number from an ordinary number to in standard form, and from a standard form number to an ordinary number. Okay, let's go back to the presentation. Ratio. Ratio, rates and proportion. Now there's also a few basic rules. Ratio never has units, fractions, mixed numbers or decimals. So if you get a simple ratio, like there's money, there's money, thank you. There's money, $35 and $56. So first of all, the dollars must be out. So it becomes 35 to 56 without units. Now I look at the two numbers. Is there anything that can go in both, that can divide into both? Yes, 7 can go into 35 and 56. Therefore, I divide the 35 by 7 and get the 5. And I divide the 56 by 7 and get the 8. If we look at number B, there we have fractions, 2.5 to 3/5. Now either I can make it all fractions and not a mixed number, the 2.5, or I can make it decimals. It's the easiest maybe to make it decimals. 2.5, that's 2.5, and 0.6, that's 3/5. Now there may be not any comma in the ratio. So I multiply both sides by 10. 2.5 times 10 gives 25. 0.6 times 10 gives 6. Now I got rid of all the decimals. Now I look, is there any number that can divide into the 25 and also into the 6? Of course, there is no such number, so that's my final answer. If we look at number C, there we see we've got different units, meters and centimeters. So your first step is to get rid of to get it to the same unit. Meters must become centimeters. Now we all know there's 100 centimeters in 1 meter. So 2.1 times 100 gives me 210. But the units are still there, centimeter, and then 269, which is already centimeters. Now I've got the same units. The moment I've got the same units, I can leave the units out and make it a ratio. 210 to 69. Now I look what can divide into 210 as well as 69. And I see 3 can go into both. So 210 divided by 3 gives me 70, and 69 divided by 3 gives me 23. Now, very important, the examples in the learning activities, they are very important. You can expect the exam questions to be like the questions in all the learning activities. If you go through all the learning activities, then you're quite on par with for the exam. So there I said learning activity number 3, you have to go through it so that you can prepare this part. Our next slide, ratio. Now it's very, very important that you read the question. What is asked? Is all the ratios asked? Is all the different parts asked? Or is just only one of the parts asked? Right, let's look at number 1. Blue, black and yellow discs are in the ratio 2 to 3 to 5. There are 60 discs. What's my question? How many black discs are there? So I look at 2 to 3 to 5. First of all, I see there's 2 parts, 3 parts and 5 parts. So together there's 10 parts. The question is, how many black discs? Which one is the black? Blue, black, yellow. That's the order. So the black is standing in the middle. Therefore, black has got 3 parts. So of the 10 parts, 3 parts will be the black discs. Therefore, 3 out of 10, 3/10 of the total amount, which is the 60. 3/10 of 60 is then the 18, which is black discs. Now, please don't go and work out the blue discs, which is 2/10, and the 5 parts, the yellow disc, which is 5 parts, because it's not asked. It's not asked. If I say, give the number of discs of each color, then you have to work out 2/10, 3/10, and 5/10. So then you say there are so many blue discs, so many black discs, so many yellow discs. Always go back to your question, see what is asked, and answer exactly that, what is asked. Never work out what is not asked. Number 2, there's boys and girls in a class in the ratio 3 to 5. Now remember, the word boys are mentioned first, meaning the 3 parts are the boys and the 5 parts are the girls, boys to girls. Now there's 12 boys. So this is not the total number of learners in the class. The boys, 12 boys. So, which are the boys? There's 3 parts. 3 parts of the class is boys. Now I know that the whole class must be 8 parts. 3 parts boys, 5 parts girls. So 8 parts are the total class. I have the 3 parts. 3 parts is 12. So if I go back to 1 part, and that is your secret here, you always go back to 1 part. 1 part. 12 is 3 parts. 12 divided by 3 is 4. So 1 part is 4. How easy is it now to get 8 parts? 4 times 8. And that gives you 32 for the total learners in the class. But very important, look at the question and be very careful to answer exactly what is asked. Now, direct and indirect proportion. Direct proportion is when one quantity gets bigger, the other one also gets bigger. And if one quantity gets smaller, the other one gets smaller. Like, one book costs $5, so 2 books cost 2 times, 3 books cost 3 times, etc. Indirect proportion, however, is just the opposite. As the one gets bigger, the other one gets smaller. So 10 men can build a wall in 2 days. If there are fewer men, they will take longer. If there are more men, they will take less time. So that's very important when you read your question. First of all, sit down, decide for yourself, is this direct? Is the one get bigger, the other one gets bigger? Or is it indirect proportion? If the one gets bigger, the other one gets smaller. That is the main thing to ask yourself and to first sort out before you can start answering the question. So let's look at direct proportion. I use 60 grams of sugar and 150 grams of flour for a cake. For 100 grams of sugar, how much flour do I need? Okay, now the best way is to make this little table. You always have two quantities, the sugar and the flour in this case. Now make a little table with 2 columns and 3 rows. Now you write on top sugar, flour. What is given? 60 grams of sugar, and you write the 60 at the sugar. Flour, 150, you write the 150 in the column for the flour. Now what is the question? 400 grams of sugar, so the sugar is given. So you write in the sugar column the 100. And your unknown is the x. So we want to know the flour, and that gives us the x. Now, is this direct proportion? Yes, this is direct proportion, because as the sugar gets more, the flour will get more. If the sugar gets less, the flour gets less. Now I cross multiply. If I have the column like that, I just cross multiply the 60 crosswise with the x. 60 times x equals 150 times 100. So if we write it down, we can say 60. Let me just make a column, and then we can see how it works. There's your unit, your topics. You multiply crosswise like that. So 60x, and then comes the equal. The moment you've multiplied that, then after the equal sign, it's the 100 times 150. Then I want to get the x alone. So I have to divide by the 60 to get both. So what I actually do is this, which you don't have to write down, but you can if you want to. So now the 60s are gone, and I've got x is 100 times 150, divide by 60, and I work that out to get my answer, which is then so many grams flour, and if you work it out, of course, it's 250, and that's your answer. For indirect proportion, the next slide, let's look at that. 12 bags of food is enough food for 32 sheep for 6 days. How long will the same food last when there are only 24 sheep? Now, exactly the same, you make your 2 columns. You say days and sheep. So I write there days and sheep, I make the columns, and there's six days that the bags of food will last for 32 sheep. The 12 bags is a constant. It's nothing to do with my problem. My problem is there's enough food for 6 days for 32 sheep, and now if there's only 24 sheep, so I write the 24 underneath in the sheep column, and I want to work out what is the x, meaning how many days. So how long, how many days will the same food last for 24 sheep? Now if we first decide, is this indirect or direct proportion? If the sheep gets more, the food's going to be finished much sooner. So if the sheep gets more, the days will get less when the food lasts. If the sheep gets less, the days will be more. So this is indirect proportion. First you have to decide for yourself, this is now indirect proportion. Now how do we go about it now? Now I multiply, not crosswise, but I multiply horizontally. So I write 24 times x, x times 24, There's my 24x, then the equal sign, 6 times 32. And to get my x alone, of course, I must divide by the 24 both sides. You can write it or you can leave it out. Now the x is alone. Can you see the 24 has cancelled? And I've got my final answer, 6 times 32 divided by 24. And I get my answer 8. 8 days. Now always go back to your question and see. There's less sheep, so there must be more days. And it corresponds with my answer. So there's more than 6 days, so it's a little bit less sheep, a little bit more days. So there you are. That covers direct and indirect proportion. Let's do study unit 2. Sorry, I go back to that one. Learning activity number 4. If you go through all those examples and you master them, you will be prepared for the exam. The next unit, money, interest, hire purchase, tax, municipality bills. So there's a lot, and some or other question, at least two or three of the topics will be covered, but at least 2 will be there. So there's simple interest. Simple interest, you just work out so many percent of the amount that you invested times the year. So it's a simple formula. The rate, 5%, 5 on 100, remember percent stand for 100, divide by 100, of the 7,000, how many years? Times 4, and that is your interest. Look, I've put it in bold letters so that you see that's the interest. Now I could ask, what's the interest only? Or I could ask, what is the total investment after 4 years worth? So then you have to take the interest and add it to the 7,000. 7,000 plus 1,400, and $8,400 is then my total amount of my investment after the 4 years. So again, read very carefully what the question asks, and not just think it's the total amount or it's just the interest. Read very carefully. Is it only interest asked? Is it both? Or is it just the total amount? Then we get to compound interest. Now compound interest works a little bit different. At the end of every year, the interest that you've earned is added to the sum, to your amount that you invested. So if you look there, the first year, I've set it out very clearly. 5% of the 7,000 is $350 in interest for the first year. This interest should be added. Now we add it to the 7,000. Now I've got 7,350 in my bank. And for the next year, I get 5% on the 7,350. It means your interest also earns money for you. So the next year I get a little bit more interest, that $367.50. Now, if I have to work it out for 3 years, I had to add this again to the 7,350. And you can go on like that. First year interest, add it. Second year on the new sum, get the interest. Add the interest. Now you get a new sum and you work it out year by year. For this question, it's only 2 years. So there's your 2 years, and if the question asks the interest, you see there, the first year you earned $350. The second year you earned $367.50. So the total amount will be adding both of them, which gives you $717.50. That's interest. If the total amount of the investment is asked, you have to take the starting amount, which is 7,000, and then you add the total amount of the interest for the 2 years, which is the $717.50, and you get your total amount, your final total amount of 7,715.50. So there's also examples, some more examples, learning activity number 6 and 7. Please go through them, see that you master them very well. Then we get to bills. Now, that's not difficult, but you have to also be careful. Read carefully your question and read what is given. If you have to go to readings, your electricity reading, your consumption reading, remember it's always the current reading, the newest reading, which will be the biggest number, minus the previous reading, which will be the smaller number. And that gives you your usage. Then your usage is usually multiplied with the cost of 1 unit. If you have used so many units, then times the cost of 1 unit give you a total amount. So the total of all the services will be the total amount payable for that month. And if there's interest also added, you have to get first the total amount and then add the interest. There's very good examples in the learning activity number 10. Please do that and master that. Now, hire purchase. If you've done a few of them, you'll see they all work the same. Hire purchase works like this. You have to pay a cash deposit. Now, the cash deposit can be a fixed amount, which they will say in the question. This is the cash deposit of $500 or $600, or whatever the case is. Then you subtract that from the selling price of the article. You subtract that. What is left? What is left, you have to pay in your installments. So, and there can also be interest added. So read carefully. Let's look at this one. A cash price of a car is $250,000. If the deposit is 15%, see, that's not a fixed amount given, it's 15% of the selling price. And followed by 10 monthly installments. Find the amount to be paid every month. So you first work out the 15%, which is the $37,500. Then, of course, you've paid that already. Now you owe less. You owe the $250,000 minus the $37,500. And you're left with $212,500. So there's 10 monthly installments. So you divide the $212,500 by 10, which gives you $21,250 for each installment. Also, read very carefully what the question asks and then answer only what the question asks. Go through the examples. Learning activity number 11. Now we get to income tax. Now, income tax is not really that difficult. You just have to understand this table. This table will always be given to you in the exam. Whether it's the same one or maybe some table with other values, it doesn't matter. The working with it is exactly the same. There you see 2 columns and you see all the rows. First of all, there's 24,000 or less. Now, if you earn 24,000, and remember, this is always per year. It's 12 months, 12 salaries added together to give you 24,000. If you get 24,000 or less, you don't pay tax, no tax. So, over 24,000, but less than 40,000, you pay 17.5% of only that salary which is more than the 24,000. So you always have to subtract that. Now if we look at the question, let's just look at the question. You first add all the tax-free allowances. Now what is tax-free allowances? It's things like maybe pension fund or things that you don't pay tax on. And they will say that. They will say tax-free allowances will be the pension fund, that, and maybe medical or whatever they tell you in the question. Now, this is the question. A man earns 40,000 per year. That's your yearly salary. The tax-free allowances are 2,500 and 3,000. So they give you that, either one amount, or they give you different ones which you have to add. All the tax-free allowances you always add together. So there we add the 2,500 and the 3,000 to get 5,500. Now what happens to that? I take my income per year and I subtract the 5,500. So you see in the next step, I take the 40,000 which I owe in a year, which I earn in a year, and I subtract the 5,500 to get 34,500. So that's my taxable amount. They call it the taxable amount. I must pay tax on 34,500. But now I go to the table. I go back to the table and I look, where does 34,000 fall? Not in the first row, because it's more than 24,000. In the second row, yes, it's more than 24,000 but less than 40,000. The other rows are not applicable. That's for higher salaries. So I stick to row 2. 24,000, above 24,000 but below 40,000. Now look at the second column next to that, for 24,000 till 40,000. You pay 17.5% tax on everything that's above the 24. Remember, the first 24 stay for free. That stays for free. So if I earn my amount there, 34,500, I subtract the 24,000. And then the rest, that what is left, the difference, I work out 17.5% of that. And that's my taxable amount. So there you can see 17.5%, 17.5 on 100, times, now what is that? The 34,500, which is my taxable amount, minus the free 24,000 that I get for tax free. That gives me the 10,500. That's why my equation now reads 17.5% of the 10,500, and I work that out to get the 1,837. That is my tax that I have to pay in that year. So there's also some more examples on learning activity number 12. And please go through them, work through them, look at the answers. You always just work with that number above in that column where you, in that row where you picked your row where the salary falls. And then it will always work out right. Look in the category where it falls, and then follow the instructions of that category. If we look back to the table, you'll see there exactly what you have to do. You do exactly what's standing there, and then you will have no problems. Study Unit 3 is about volume, surface area, and cubes. Now also, you need to have some pre-knowledge. You can't work out volume or areas if you don't have the basic knowledge of length and breadth and height and so on. So if we look at the volumes, here you have volumes of cubes, cuboids and cylinders. So the volumes of cubes, there's a cube, the first one, length, breadth and height is exactly the same. The second one we call a cuboid, and you also need to name the words. You need to name that is called a cuboid. It can be asked. There's length and breadth and height different. The two of them can be the same, can be a square base and a different height. Then a cylinder, there's the cylinder, third sketch, and there's the diameter giving and the height. Now let's look at the volume first. The volume, if you look there, there's a basic formula. Base area times height. If the base is a square, it's the area of a square times height. If the base is a rectangle, it's the area of a rectangle times height. If the base is a circle, it's the area of a circle times height. So that's very easy to remember. Whatever the base is, that area, that formula, times height. The first one, base area, there's a square, 5 times 5, that's my base, times height, times 5, which gives you 125 cube centimeters in the end. The volume of a cuboid, base area is your rectangle, length times breadth, 3.2 times 2 times height, and that gives you the final answer. And the volume of a cylinder, of course, is the base of a circle, circular base times height. And what's the area of a circle? Pi radius square. So pi radius square, that's my base area, times height, that's 60. So that is 314,16 times 60, which gives me the final. Now, if the question doesn't say, you can round it off to 2 decimals or 3 significant figures. If the question doesn't say, or you can give the full calculated display, all of them will be marked correct. But if the questions say round off to 2 decimals or round off to 3 significant figures, you have to exactly do what the question says. And again, before I go on, pi. Always use pi on your calculator. Never use 3.14 or 22 on 7. Sometimes it's given, but it's best to use pi on your calculator. You have a key there. Sometimes it's a shift key, a second function key. If the pi is not on the key itself, but you use pi on your calculator. That's the safest, that gives you the most accurate answer. Now we get to total surface area. Total surface area of cubes, cuboids and cylinders. Again, the 3. Now, also I have a basic formula which you can learn, and then you don't have to learn all the different formulas. If you can get the perimeter of the shape times the height, that'll give you the surface area of the 4 walls. Perimeter going once around times height is the 4 walls. Then the roof and the floor, as I usually call it. The roof and the floor, that's exactly the base area. It's the same base area you used in the volume. So, but you have 2 of them, the base, the floor and the roof. So that's why the formula is perimeter times height plus 2 times base area. So first perimeter, you go around once. There's your square, 5 plus 5 plus 5 plus 5. That is your perimeter. 5, 10, 15, 20. 4 times 5 is 20. That's the perimeter. Now times height, times the 5, that'll give you the 4 walls. Done with that. Plus 2 times the base area. What's base area? Length times breadth, 5 times 5. So that gives you your 20 times 5, which is 100, and 5 times 5, which is 25, times 2, which is 50, and total of 150. And this time, it's area, it's square centimeters. The total surface area of a cuboid, again, perimeter, going once around times height. Going once around is the 3.2 plus 2 plus 3.2 plus 2. Or 2 times 3.2 plus 2 times 2. That gives you 10.4 if you go around once. Times the height, 1.4. So that's the 4 walls. Plus the roof and the floor, 2 times base area. What's base area? Length times breadth. 3.2 times 2. And there's your final answer. Again, square centimeters. Cylinder, exactly the same. But in a cylinder, we don't call it perimeter. When going around once a cylinder, going around once a circle, we call it circumference. It's just another word, but it's again the same meaning, going around once. Now, what's the circumference of a circle? Pi times diameter. Pi times diameter is your circumference, going around once, times height times the 60. Plus, now the base area. Remember, base area of a circle stays 2 pi radius square, pi radius square, 2 times of that. And you see I have given you many digits after the comma, so to keep your answer as correct as possible. So the pi times diameter was pi times 20 times the 60, and you have the answers there. Just check and see on your calculator if you get the same, and now we have the answer there. 4,398 square centimeters. We rounded it off to the nearest whole centimeter square. What if I ask liters? I've put this in also to make you aware of that. Remember, this is total surface area. It's not volume. I should have put this at the volume. So please just delete that last answer. We should have done that at volume. Now if we look at that, just delete that last equal sign, scratch it out. Then if we convert cube centimeters to liter, 1 cube centimeter is 1 milliliter. So if I go back here, there I've got the cube centimeters there at the cylinder. So there's 18,849,56 cube centimeters. So let's make that liters. Now, cube centimeters is the same as milliliters. Remember, 1 milliliter, 1 cube centimeter. So there you are. You've got 18,849 milliliter. If I round it off, it is 18,850 milliliter. How many milliliter in a liter? Say 1,000. So I divide by 1,000, so I get 18.85 liter. So very important, I can ask if your answer in liter. Remember, 1 cube centimeter is 1 liter. If I go back to that one, remember that the last answer, you just delete that, please. We stop at square centimeters for area. Of course, you can't convert that to volume. So now we get to study Unit 4. Geometry of triangles, bearings, enlargements, polygons, and circles. Although this unit concentrates on polygons and circles, the previous knowledge here is important. You have to know all the previous knowledge of parallel lines, their properties, of angles, of triangles, properties of triangles, all the triangle theorems that you had in the past. You have to know them because it's going to be applied all together with the new knowledge. All the different kinds of quadrilaterals, squares, rectangle, trapezium, rhombus, kite, etc., and their properties. This is pre-knowledge that you need to know. And all quadrilateral theorems, you need to know their properties. So you first have to master this basic knowledge, and then we can go on to geometry. So angles of similar figures are equal. Similar figures are, you can actually see it as enlargements. The one is an enlargement of the other one. The angles, they do not change. But the sides, they are in the same ratio. So if we look at this one, find the scale factor. 70 you've got 14 in the small one, 70 in the large one. So what happened to the 14? 14 times 5 gave me the 70. So what happens? All the sides times 5, small one times 5 gives the big one. Or the big one divided by 5 gives you the small one. 70 divided by 14 gives you 5. That's the scale factor. Now the 25 is a side of the big figure. 25 I must divide by the scale factor 5, and it gives me my answer 5. So the side of that small figure that's asked is 5. Learning activity number 15 will give you more examples. So let's look at 3-figure bearings. Remember, you always face north. You face north and you turn clockwise. You stand at the place where that comes after the from. Find the bearing of B, from A. So from A, that's your key. You go and stand, put yourself there at A and you face north. Now you start turning. Your head may not turn, you just turn your body. And you turn until you can see straight, you look straight at B. You have turned through 110 degrees. So the bearing of B from A is 110. Find the bearing of A from B. So now I go and stand at B. Now this is important to see that the co-interior angle is 70. The co-interior angle, if I look at the sketch, NBA, that's 180 minus 110, because those two angles are co-interior angles which add up to 180. That is pre-knowledge which you need to know. You need to know alternate angles and co-interior angles. Corresponding angles also, but we don't use it so much in bearings. So you stand at B. Now can you see you turn through 180 until you face A. So I've turned through 360 minus 70. Can you see where the 70 comes in? I have to know that top angle, the NBA or ABN angle. 360 is the whole revolution. Minus the 70 gives you 290. So the bearing of A from B will be 290 degrees. Learning activity 16, there's some more questions. Enlargements are actually very clear in your guide. You can go through those formulas. It's always either the big one is mapped onto the small one, but we actually concentrate on the scale factor bigger than 1, which is the small one enlarged to get the big one. And remember, you must join all the edges, the points, the vertices, and then you get the center of enlargement. The center of enlargement is very important if it's asked. You have to join the lines like there in the example. How do I get the scale factor? I divide the big side by the small side, just like the previous question. So I can say there's a difficulty. There's 3 blocks on top and the small one is 1.5. Why don't I just go to the side, that's the right hand side is exactly 2 blocks on the black figure and 1 block on the blue figure, the small one. So 2 divided by 1 gives me 2, scale factor of 2. Or if I take the 3, I must carefully see that the blue line is 1.5 block. And 3 divided by 1.5 also gives me 2. So the scale factor is 2. How do I get the center of enlargement? I combine the vertices just like that in the dotted lines in the sketch. So now your answer must contain 3 things. It's an enlargement, scale factor 2, and the center of enlargement you must give as coordinates, 0, minus 1. If it's the origin, you can say the center of enlargement, the origin. But that's only the origin. All the other centers, in all other places, you must give as coordinates. The x and the y coordinates, 0 and the minus 1. There's some more exercises and learning activity 20 and 21. Please do them because you need the exercise. Now polygons, we have the names. Please learn the names, that you know them all. The sum of the exterior angles is the easiest to start with because of all of them, hexagon, heptagon, octagon, all of them, the sum of the exterior angles is 360. To find one, of course, I take 360, which is the sum of 5 or 6 or 7, depends on how many sides the polygon have. That's the N, stands for the number of sides. If it's a pentagon, it will be 5. If it's a heptagon, it will be 7. If it's a hexagon, it will be 6, etc. So the exterior angle of a regular triangle, there is 3 sides. 360 divided by 3, the exterior angle will be 120. As you can see, where's the exterior angle there on the sketch, the figure there. Exterior angle of a regular hexagon, a hexagon's got 6 sides, so you just divide the 360 by 6 to give you the 60 degrees. Now to work out the interior angle. To work out one interior angle, if I have this exterior angle, can you see that the exterior angle and the interior angle are on a straight line? So, what is a straight line? 180 degrees. You can just subtract the 60. So then you can just subtract 120 to get 60. So the sum of interior angles of a regular polygon, if we look at the sum, we want all 3 or all 5 or all 6. And there we have the formula. It's always 2 less times 180. So if we look now at any polygon, n sides, we call it n sides. There's so many sides. 3 sides, 4 sides, 5 sides, 6 sides. N minus 2. So you subtract 2 times with 180. To get 1, you divide by the n. You divide by 6. Not by the 6 minus 2, divide by the 6. So one interior angle of a regular pentagon. Pentagon's got 5 sides. So it's 3 times 180. Then that's the sum of all 5. Divide by 5 gives you 1. The exterior angle of a heptagon. Heptagon has got 7 sides. 7 minus 2, 180 times 5. That's the sum of all angles. The 900 is the sum of all angles of a heptagon. Divide by 7 gives you 1 angle. Now the angle properties of circles that is new work. The circles, there's a few things you need to know about circles. I think you know that the angle in a semicircle is 90 degrees. If not, this is the first one you have to learn. Angle in a semicircle is 90 degrees. So if you look at this sketch, that B is 90, A, B, C. And if you look at the sketch, the bottom one, ADC, can you see AC is the diameter? So ABC, that is your 90 degrees. ADC, that's your other 90 degrees. Now, if we look at the 3 questions there, find the size of angle CAD. CAD. Now, first of all, that CAD is 42 degrees. ODA is 42 degrees. But you have to look at the whole triangle. Look at that small triangle, AOD. Can you see that OA and OD are the same? They're both the radius of the circle. AO and AD, meaning this is an isosceles triangle. So base angles of an isosceles triangle are equal, so you don't even have to work anything out. OAD or CAD is 42 degrees. Now they want to size the angle of ACB. ACB. Now first of all, you know that B is 90. And the second angle in the whole triangle on top there is 24. So I can just add 90 plus 24 and subtract it from 180. Or I know the B is 90, so 180 minus 90 is 90. 90 must be the 24 plus the angle at C. That's why I can just say BAC is 24 given, but BCA will be 90 minus 24, which is the 66. Then the last question is BCD. Now let's look at BCD. Can you see it's the big angle BCD? What do I need? I need that angle which I just worked out, BCA, which is 66. I got that, or ACB, doesn't matter how you call it, ACB or BCA. We worked it out 66 degrees. Then we must work out ACD and then add it. And ACD we can work out. We have ACB, of course, that's the 60 we worked out. We have to find ACD. ACD is half of AOD. Why can I say that? Can you see that AOD is the angle at the circle, at the center of the circle? And ACD, A center D, AOD, A center D, angle at the center. ACD, A circumference D, angle at the circumference. And the angle at circumference is half the angle at the center. Now I can work out AOD because I've got the two 42s, 42 and 42. That gives me 84. So 180 minus the 84, so ACD is then 96. 180 minus the 84 is 96. Therefore, 96 divided by 2 gives you the angle at the circumference. Angle at the center is double the angle at circumference. Angle at circumference is half angle at the center. So therefore you can just divide that AOD by 2 to get the angle at the circumference. Now we're not finished yet because we have to add BCA and ACD. We've worked out both and we add the 66 with the 48 to get 140 finally for that question. You can expect all the theorems, few of them, 1 or 2, to be asked in one question. And also your previous knowledge, like isosceles triangle, those angles are equal. Equilateral triangle, all 3 angles are equal. And that knowledge can be applied into some of the questions that is asked. Learning activity number 24, that will give you some more questions and some more exercise. Please go through it, study it, master it. So that is, we are now halfway. Study unit 5 is the next 4. We've covered now 4 units. So I think we can make a break here and make a second presentation starting from study unit 5.